Hello all, welcome to the Mechanical Engineer. In this video, we are going to see the process of finding the moment and the resultant of non-concurrent forces. Finally, we are going to find the location of the resultant force. So before going to the resultant force, first let us see how to find the moment. So first, the moment is a rotational force. So the equation for moment is force multiplied by perpendicular distance. So this is the equation for moment. So for example, I have considered a force system. So the ABC is a structure and the 80 Newton is acting with the inclination of 30 degree. So we know that whenever a force is acting with some inclination, then we will resolve this into two components, the horizontal and the vertical component. The magnitude of the horizontal component, we know that it is 80 cos 30 degree. Similarly, the magnitude of the vertical component is 80 sin 30 degree. Okay, now we have resolved the force into two components. So let us find the moment. So I'm going to find out the moment at the point A, at A. Okay, fine. So first consider the 80 sin 30 degree. So that is equal to 80 sin 30 is actually the force and multiplied by the perpendicular distance. So remember that the 80 sin 30 is acting in the vertical direction. So the perpendicular distance will be in the horizontal direction. Okay. So this is the line of action of 80 sin 30 and this is the perpendicular distance from the force to the point A because we are calculating moment at point A. So the distance is 20 mm. 20. In moment, we have to consider one more thing, that is the direction. So I'm going to consider that the clockwise moment is considered as positive. So you can choose any one direction. I'm considering clockwise as positive. So now coming to the 80 sin 30. So this is the fixed point and this is the line of action of the force. So the 80 sin 30 is acting like this. If it goes like this, then this force will make the system to rotate in the anti-clockwise direction. So it is considered as negative. So it is minus 80 sin 30 into 20. Now coming to the next force, it is 80 cos 30 degree. So here, this is the line of action of the force and the perpendicular distance between the force and the point A is the vertical distance because the force is acting in the horizontal direction. The distance is a vertical distance and it is 10 mm. So the distance is into 10 mm. So we have considered force, distance. Now the third one is the direction. So this is the line of action of the force. And if I fix this force at the center A, then this will make the system to rotate in the clockwise direction. So this will not go like this. This will only go like this. So it is clockwise direction. So we have considered the clockwise as positive. So this is the moment because of these two forces. Okay, so now we can solve this and we can find out the moment of these two forces at point A. So this is how we have to find out the moment. And coming to the location of the resultant, we know that based on the horizontal and vertical forces, we can mark the coordinate, the quadrant and the direction of the resultant. For example, we know that in the resolution of forces, we have considered the horizontal right side as positive and vertical upward as positive. So in case if our system has a positive horizontal force, then this is going to be our sigma h, and if it is having a positive vertical force, then this is going to be our sigma vertical, and we know that the resultant will be in between these two, or this is going to be the alpha. So this is the magnitude and the direction of the resultant. Now to locate the resultant, for example, I have considered this square box and let us say we have found out the resultant of this. So we have to find the distance between this sigma h, sigma v, r and the point we have considered for calculating the moment. So in the moment you will get the directions. For example, if you get the negative sign, it means that the moment is acting in the counterclockwise direction. If you get positive sign, then it is acting in the clockwise direction. So now let us say we got a negative moment here previously. So I'm going to locate this. So somewhere in this square, I'll get sigma h like this, sigma v like this, and the resultant will be like this. So this is actually the line of action of the resultant. So now I can also draw a sigma h and sigma v here because both are same. The line of action is going to be same. So with this, we can find out three values. One is the perpendicular distance from R to the origin. It is considered as Z. Next one, the distance between vertical force and the origin, that is X. And the distance between the horizontal force and the origin, it is considered as Y. Okay. Now, as per Varignon's theorem, the summation of moment about O is same as R into Z. Okay, if you are considering the direction, if the summation of moment about O is acting in the negative direction because it is acting in the anti-clockwise direction. Now, to take the resultant moment, the resultant is also acting in the anti-clockwise direction. So, we can take minus R into Z, and we know the magnitude of the R, and we can find out the Z value. Similarly, for finding the X and Y, you can write the Varignon theorem as summation of MO is equal to sigma V into X. This is force into perpendicular distance. So, sigma V is the force and it is the perpendicular distance. So, here the sigma V is acting in the counterclockwise direction. So, let us consider the negative sign here. So, mostly your movement will be also in the negative sign. So, with this we can find out the value of X. Similarly, the third one, summation of moment about O is same as sigma h into Y. So, if you consider sigma h here, there is no perpendicular distance because the line of action coincides with the origin. But if you consider here, there is a perpendicular distance, that is Y. So, it is sigma h and the perpendicular distance is Y, and this is acting in the counterclockwise direction. So, I can put negative sign here and I can find out the value of Y. So, this is how we can find out the perpendicular distance Z, X and Y, and we can locate the resultant. So, let us solve a problem on that so that you can get some idea. So, this is the first problem I have considered. Figure shows a coplanar system of forces on the flat plane. Find the magnitude, direction and location of the resultant. Okay. So, first starting with the resolution of forces, let me draw the free body diagram first. Okay. So, we have 1800 Newton in the inclined direction here. So, I am making it as 1800 cos 35 and 1800 sin 35. Then here we have 1500. So, 1500 sin 60 degree and 1500 cos 60 degree. Now, the distances are, this is 3 meter and this is 2 meter. Okay. Now, we have one more force here. So, this is 2200 cos 70 degree and 2200 sin 70 degree. And this distance is 4 meter. So, first let us find the magnitude of the resultant. We know that the magnitude of the resultant R is equal to root of summation of h square plus summation of v square. So, first let us find summation of h square. Sigma h is equal to, so remember that the positive in the right side and upward. So, sigma h. So, starting from the 1500, so the 1500 cos 60 is acting in the left side. So, it is considered as negative. So, it is minus 1500 cos 60. Then this 1800 cos 35 is acting in the same negative direction. So it is minus 1800 cos 35 degree. And this 2200 cos 70 is acting in the right side. So it is plus 2200 cos 70 degree. So if we solve this, we will get the value of minus 1472.07 Newton. Okay. Next, find out sigma V. So the 1500 sin 60 is acting in the upward direction. So it is plus 1500 sin 60 degree. And this 1800 is acting in the downward. So it is negative minus 1800 sin 35 degree. This 2200 is also acting in the negative. So it is 2200 sin 70 degree. So the answer is minus 1800 Newton. Now the resultant is equal to root of minus 1472.07 the whole square plus minus 1800 square, and the magnitude of the resultant is 2325.2 Newton. Okay, so now let us locate the magnitude. Before that, let us find the direction. So alpha equation is tan inverse of summation of V divided by summation of H, that is equal to tan inverse of minus 1800 divided by minus 1472.07, and the alpha is 50.7 degree. Okay, so this is the R and alpha. So let us locate this first. So the sigma H is acting in the negative direction. So this is going to be my sigma H because it is acting in the negative direction. So I have considered the left side. Similarly, sigma V is also acting in the negative side. So this is going to be my sigma V. Now, this is my resultant R and this is going to be my alpha. Now, to find the location of the resultant force, I need the moment. So let us find the moment from the left top extreme point. So you can find moment from any places, but I am preferring this C point. Okay, left side top extreme point. So let us find the moment about the point C. So starting from the 1500 sin 60, this 1500 sin 60 is acting in the clockwise direction with the perpendicular distance of 2 meters. So this is the line of action of the force and this is the distance between the force and the point C. Okay, so it is 1500 sin 60 degree into 2. Now coming to the direction, so this force is acting in the counterclockwise direction. So it is considered as negative. Okay, fine. Now coming to 1000 cos 60, this 1000 cos 60 is acting in this line of action and there is no perpendicular distance between this force and the point C. So it is considered as 0. Now coming to the 1800 cos 35. So here also this is the line of action of the force and there is no perpendicular distance. So it is considered as 0. 1800 sin 35 is acting like this and there is 3 meter distance between the force and its perpendicular point C. So this is the line of action of the force. So it is acting in the vertical direction and the perpendicular direction is considered as the distance. So the horizontal 3 meter is considered as the distance. So the force is 1800 sin 35 into the perpendicular distance is 3 meter. Now coming to the direction, so this force will be acting like this. This is the clockwise direction because this wouldn't go like this. Okay, so this will be rotating like this and it is considered as positive. Now coming to the 2200 cos at that 70. So this is actually the 2200 cos 70. So the distance is given, it is actually 3 meter that is given in the problem. This is 3 meter. So the force is 2200 cos 70 degree into 3. And the direction of rotation is important here. This is actually the line of action. And if a force is acting in this action with 3 meter distance, then this will go like this. So this is the anti-clockwise direction. So the direction is negative here. Now coming to the last force, 2200 sine 70, it is 2200 sine 70. Coming to the perpendicular distance, this is the line of action, and the distance between the line of action and C is this 4 meter. So it is multiplied by 4, and the direction of rotation is clockwise, because this wouldn't go like this. The forces will be rotating around the center C. So it is positive. Okay. So the moment magnitude is 6517 11.3 Newton meter. So this is the summation of moment about point C. So now to locate the moment, let us draw a square here. Okay. So the summation of vertical forces and horizontal forces are acting in the negative direction. So let me consider the reaction force is acting like this with a summation of vertical forces in the negative. Also summation of horizontal is also on the negative. Similarly, I can also draw summation of vertical forces here and summation of horizontal forces here. The reason for drawing two is I am considering both the two edges, because if I consider the top edge, I can get the distance between sigma v and the point. And if I consider the vertical edge, I can find out the distance between sigma h and the point C. Okay, fine. So let us fix the point C here. And also the perpendicular distance is actually Z. The horizontal distance, I am considering it as X. And the vertical distance, I am considering it as Y. Now, as per Varignon's theorem, the summation of moment about point C is equal to the magnitude of the resultant into the perpendicular distance. This is the first distance Z. So here you can see that the R is acting in the clockwise direction. So it is considered as positive. So it is plus R into Z. Now the moment value is 6511.3. That is equal to R magnitude is 2325.2 into Z. Now the Z value is going to be 2.8 meter. So this is the Z value. Now to find the X value, let us again write the Varignon's theorem. Summation of MC is equal to sigma V into X. Because if you consider this force system, only the sigma V will be there. Because sigma H, there is no horizontal distance. So sigma V into the perpendicular distance is X. And this sigma V is also acting in the clockwise direction. So the direction is positive. So the moment magnitude is 6511.3. That is equal to summation of vertical forces is 1800 into X. Okay. So this X is equal to 3.62 meter. So now you may have a doubt that the magnitude of the sigma V is negative, but we have considered it in the positive. The reason is, so the magnitude is negative. That is why we have considered the direction as downward. So we have changed the direction. So the magnitude is now automatically becomes positive if you consider in the negative direction. So that is why I haven't considered, because this magnitude plus or minus is only for whether it is acting in the upward or downward. So we have considered upward as positive and the result came in the negative. So it means that it is acting in the downward. So we don't need to consider in calculating the distance. So similarly for the Y value, the summation of MC is equal to H into Y. So you can see the vertical edge. So sigma H into Y. So here the H is acting in the anti-clockwise direction. So here also I am not considering the direction because it is already acting in the negative side. So that is equal to sigma h magnitude is 1472.07 into y, that is 6511.3. Now the y value is equal to 4.42 meter. Okay, so this is how we can solve the problem. First, resolution of method is used, forces method is used. So with the sigma h is sigma v, then r and alpha. To find the location, we are finding the moment, and in the location we have found out three values: the z, x and y. Okay, thank you.